Our next speaker is from USGS and Peter
Weisgall.
Yep. And let's see.
Yes. Hi. Glad you all stuck it out to the end here. My name is Peter Weisgall. I'm a hydrologist with the USGS, Massachusetts, Rhode Island office of the New England Water Science Center. We're, for the most part, based up in Massachusetts, but we also are frequently down in Rhode Island meeting with the Water Resources Board and the RIDEM and other cooperators with whom we do studies. And primarily our number one mission is stream gauging and measuring stream flow in all the rivers of Rhode Island, as well all the major rivers, as well as rivers across the whole country. And today I'm going to really focus in on the sort of the beginning of the whole story. Before the water treatment plant, and certainly before the wastewater treatment plant, there's the source water for our drinking water systems. And let's see if I get the page down button here. Page down. There we go. What we're doing currently in terms of water quality in the state is, as I said, we're monitoring for source water protection with a focus on the Scituate reservoir. As you know, that supplies water to the largest single group in the state that is on public water for the city of Providence. We also maintain a water quality monitoring network with the RIDEM that is helping them comply with the Clean Water Act and reporting for the 303D list. Also, their efforts to do TMDL's total maximum daily load studies within the state. And then finally, we're working, we have what we call informally a superstation at the state line at in the Blackstone River. This is an automated, continuous water quality and stream flow station right at the state line on the Blackstone, monitoring what's coming in from Massachusetts into Rhode Island and ultimately Narragansett Bay. In terms of the Scituate, we are maintaining and operating near real-time stream flow and water quality monitoring capability at about 8 locations in the tributary streams. In other words, we're looking at what the watershed is contributing to the reservoir. It's an early warning system for alerting managers to potential source water problems. And we're also looking over the long term and the short term at trends. You know, what's going up, what's going down in terms of constituents that are of concern, chloride, nitrate, and nitrogen in general, bacteria. You know, are there trends that are of concern that have to be looked at in terms of protecting the source supply? So here we have the major tributary basins to the reservoir. And all of this is, by the way, documented. Don't want any of you to leave without taking one of our annual reports for the Scituate, in which there's a lot of documentation of the land use, water quality, and just the overall hydrology of the basin, of the Scituate Basin. These are some of the important points to make about the basin, the watershed. 600,000 people, as I said, are supplied. 94 square mile drainage basin. About 97% undeveloped, which is very important, but only 29% of the area is protected. So for that reason, it's very important to keep monitoring, to track what effects development are having, including highways and state and local roads. Close to Providence and Hartford, so it's subject to sort of the outer edge of development from the two metropolitan areas. And portions of it have rapidly growing residential development. Okay, I mentioned the roads. This is actually very important because it relates to sodium concentrations, which there are secondary standards, Safe Drinking Water Act standards. And you can see the statistics there. Fair number of state highways, road miles, even larger number of locally maintained roads, and then private and small roads and trails. Now here's an example of the type of station that we have located on tributary streams. This happens to be about the most basic kind of monitoring that we do, which is continuous temperature and conductance in the streams. In addition to the monitors, the automated monitors, we're out monthly at all of these sites collecting samples that go to the USGS National Lab for a whole series of constituents. And as you can see, 34 monitoring stations from these major tributary basins. And I might add, we're focusing on this set of stations, and Providence Water Supply Board staff do a whole additional set of stations. We're not at all of these ourselves. This is an example of some of the types of data that are collected pretty much continuously, that's to say all the time. And we have total precipitation, the portion of precip that is just snowfall, which is actually very important to know because of the whole following set of graphs, which is looking at chloride load associated with road salt primarily. And as you can see, after some major storm events, snow events, like right here, it's followed by a big peak in the chloride load expressed here in tons associated with particular basins. So we have the Ponegantsit River here, the Petoe Brook near North Scituate, and Honeyhouse Brook near North Scituate. So these are example tributary basins, and the actual load of chloride and the sodium is fairly, as you can imagine, tightly related to the chloride associated with those basins. Now, here are two graphs that show some relationships that are really revealing about sources of this particular contaminant. And here we're looking at sodium. So these are analyzed, lab analyzed samples. Chloride is pretty much inferred from a relationship with specific conductance or conductivity. For the state-maintained roads, there's a pretty tight relationship between the road density in lane miles per square mile and the actual concentration in that, or upstream of that sampling point on the stream. Whereas if you look at locally maintained roads, there's a much more noisier, non-significant relationship. Those of you who know your statistics, the p-value is very low here. That's to say there's a very significant relationship, whereas with the locally maintained roads, it's a weak relationship. So what this says is that for the larger state-maintained roads, control of what is applied during snowstorms and after snowstorms is really important for protecting the source water quality. The net effect at the local level seems to be less pronounced than at the state load or the state-owned larger roads. This is a detailed analysis, all of which is described in this particular interpretive report on which basins and trends within each basin in chloride load and in chloride yield. A yield is a load per unit area of drainage basin. Again, for the major tributary basins to the Scituate Reservoir. And essentially the size of each circle is proportional to the load at that particular point of drainage. Here we have something that our previous speaker from Warwick, Betty Ann, was focusing on, which is bacteria, which is a major problem, of course, for both receiving waters and for drinking water. And there are fecal coliform bacteria in the source water. As you can see here, the yield, that's to say the bacterial load per unit area, is highest over in these basins, which are in the most developed area. Now, that could be to some degree from septic systems. Most likely, however, it's stormwater runoff associated with a higher road density. So when you correct or normalize to drainage area, you can see that the yields are considerably higher here, as well as the loads being high. So it's valuable to have both loads and yields represented in the interpretation. Okay, nitrate and their trend is what's represented here. In other words, over time, is there a statistically significant increase or decrease? The good news is that for the Scituate Reservoir tributaries, the trends are mostly downward with respect to especially the recent data, 1996 to 2002. There are some upward trends. This may be due to trends in more developed areas, but this is good news, and it shows some of the success of watershed protection that's going on with this particular system. Now I'm going to say a few things about our water quality monitoring network, which is primarily with the DEM and primarily oriented to the Clean Water Act requirements as opposed to Safe Drinking Water Act. And we're monitoring nutrient and trace metal concentrations and loads at 6 stations across the state, mainly large river stations. Hopefully you can read this. Essentially, these are the stations of Blackstone at Millville, which is the state line, Massachusetts to Rhode Island station on the Blackstone. The branch at its mouth, or near its mouth, with the Blackstone River at Manville, further downstream. The Blackstone at Roosevelt Ave in Pawtucket, and then the Patuxent near its mouth, which should be in Warwick, I believe. Somebody can correct me here if I'm wrong. So that's where the stations are. What we do when we're monitoring at these stations, we collect what's known as equal width increment samples in a flow proportional manner, so that we are, say, every foot or so across the cross section, we're sampling the water proportional to the rate of flow in this sampling device. That way you get an accurate picture, not just of the concentration, but of the load. The concentration times the flow. And the load is as important as the concentration when dealing with the river. Here we have the Blackstone near its mouth at Pawtucket. And this is showing an automated sampler, an ISCO sampler, that is withdrawn from just a point in the river, but we compare and we in fact rate that point sample against the cross section so that we know what kind of correction factor to use to get a reliable estimate of the whole cross section when we're doing automated sampling. Now here's some trends. Fortunately, USGS, we've been around a long time and we've been doing sampling at some of these sites for decades. Specific conductance at the state line gauge on the Blackstone River is showing a general upward trend. This has more to do probably with urbanization and non-point source than it does with anything going on with treatment plants on the Blackstone. And as you can see here, chloride is certainly going up over time as well. This is sort of the tip-off. Chloride is going to be more associated with road salt in general than it is in from the treatment process, but as you can see, there's a pretty clear trend upward in concentration. These are not loads, but concentrations. Total nitrogen, on the other hand, is going down over time. It's not a really strong trend, but this is showing the counterbalancing effects of improved treatment process on the one hand, but population going up on the other. So, and in this case, concentrations for nitrogen are going down, phosphorus also going down, again at a fairly slow but statistically significant rate. Now here are the heavy metals. We heard about this a little earlier from our Warwick speaker. These haven't been sampled for as long a period, but they're also showing downward trends. Cadmium, chromium, and copper in the stream at the state line. Now, the fact that it's at the state line means we're dealing with Massachusetts sources here. So, and this is naturally something Rhode Island is very interested in knowing, and as is EPA with their mandate for all of New England and Region 1 EPA, and the New England Interstate Water Pollution Control Commission, NUIPIC, which was basically founded, established to deal with these kind of interstate water issues. So I'm just going to show you what we're doing in what is really a state-of-the-art monitoring station at the state line. We are monitoring at this both stream flow and water quality at Millville, Mass. And the purpose is to get reliable estimates of nutrient, TSS, and trace metal loads crossing from Massachusetts to Rhode Island, and to the degree possible use surrogate water quality indicators to provide real-time estimates of constituent loads. An example would be turbidity, relating turbidity to particular constituents. Okay, this is an actual from flow proportional continuous composite sampling for phosphorus. That's what's shown in the line of this graph, and the points represent samples. I should say the monthly samples that are collected are where the lines occur. And as you can see, just doing monthly sampling at one of these lines, like here, you can miss the peaks and therefore misrepresent the load if you're going out there once a month. In between, January 1st and February 1st, there could have been a big storm, or a better example would be April 1st and May 1st, that carries a lot of the load, and then on an annual basis, you can severely underrepresent or misrepresent the load coming across a state line. So automated composite sampling provides a more accurate record of the total load and also variations in loads. And for that reason, if you're really wanting to see how total maximum daily load conditions are changing in a stream or in a river, conventional once-a-month grab samples, or even equal with increment samples, aren't giving you the whole picture of what is moving down the river. And this is phosphorus. These are, this is phosphate in particular, right here, the lower graph. Okay, this is location. Just get everybody oriented. As you know, of course, the Blackstone's a major river in Rhode Island, but 2/3 of the drainage basin is in Massachusetts. It basically starts up here in the Worcester area. This is very important because there's a major wastewater treatment plant, the downstream end of the city of Worcester. And there's major tributaries coming in as well, some of which have treatment plants on them, wastewater treatment plants. Now, what we have here, the red circles are the wastewater treatment plants. The squares are USGS monitoring stations. This was done for an extensive look at the whole basin. We do sample less frequently at those sites now, but our Millville station is right there, where we have this superstation located. And this almost looks like we're inside a treatment plant here in terms of the automated sampling, but this is inside a small structure. And essentially what this instrumentation does, it's almost like a SCADA. It's monitoring conditions in the stream real time. And for every, I can't give you a number, but every X millions of gallons that flow by that station that we set, we'll set a given number. I'll just pick a number, say 20 million gallons. We're taking a sample, and it's going as into a Teflon container, and on an every 2-week basis, it's also being preserved. On every 2-week basis, we come and take that container out and subsample it for the lab. So it's a flow proportional composite sample, and the sampling's happening more frequently during high flows, less frequently during low flows in the river. And we have the ability to filter these samples in real time. It's a self-cleaning filter system too. When after a certain amount of water has gone by that filter, it's actually clean. Just like in a treatment plant, you know, the backwash through it. And the end result is the ability to quantify load at locations starting upstream of these brown bars are the loads in the river. The green bars are the discharge loads from each of the treatment plants, the major treatment plants along the river. So here we're looking at Upper Blackstone Pollution Abatement District plant in Millbury, Mass. This serves the greater Worcester area. And then additional smaller treatment plants in Grafton, Mass., Northbridge, and Uxbridge. And here's the state line gauge, where the picture I just showed you is from. And here is Pawtucket, whoa, at the mouth of the river, right essentially near Narragansett Bay. So, as you can see, this particular treatment plant is the big player on the Blackstone River, and loads pretty much actually start to go down. There's reasons for that, have to do with natural denitrification. And by the time you get to Pawtucket, it's not all that different than it was well up here in Massachusetts in terms of the overall nitrogen load in the system. And this breaks it down in terms of some of the nitrogen species. I won't dwell on this too much other than to point out that ammonia drops off pretty quickly from the upstream parts down into Rhode Island. And a good amount of that ammonia is converted over to nitrate, the red bars. So the blue bars are the ammonia, nitrates, the red bars, and those stay pretty high. Total nitrogen is the purple bars. Like I said, there's some increase, but a lot happens up there in Massachusetts before it ever even gets into Rhode Island. Here's all of that instrumentation I showed you before in the picture is in this small shelter right on the Blackstone at Millville. This is in the winter, which, as you can see, the river's frozen over for periods of time. By the way, there's also a precipitation gauge, and there's landline electric power into this site. I call it a SCADA because it's reporting to our office continuously with data, just like you'd have with a SCADA. And a whole series of air temperature, water temperature. The red dots represent sampling times when we're taking samples into that composite container. And this is all happening via the web. And I think I'm going to leave it right there and just emphasize to everybody that's our website for our Rhode Island activities. And everything we're doing in Rhode Island, you can go to that website and find out about it. In particular, our our reports. This happens to be the surface water, or the water quality section of our publications page for Rhode Island. And you'll find a lot of interesting information on all aspects of what we're doing at this site. So, I think I've taken my time.
We have time for a few questions.
Any questions on Mass or Rhode Island? Yes, sir.
I had a question on your sampling. I mean, I've done some sampling using like ISCO samplers for stormwater runoff, and we've had real issues with deposition and so on, and we could never get a balance, a mass balance on water going in. We made the mistake. The mistake is you measure what goes in and you measure what goes out, and you expect that it should match because it's just going into a small, basin. Nothing's being lost, but.
Is this a wastewater treatment plant?
No, this was stormwater runoff.
Oh, stormwater runoff, sorry, yeah.
And so I was just wondering, in your case, I know there's a difference probably in water quality between stormwater runoff and the Blackstone River, hopefully. And I was just wondering if you had issues with the samplers or anything like that in terms of quality.
Well, yeah, they require a lot of care and feeding, and you have to be, turbidity and particulates are the real enemy of this type of sampling, and unless you're monitoring it, and having in effect a SCADA system like this on hand to know every day what's happening is essential. And of course, with the web now, you can monitor these types of stations continuously.
I was going to ask you that too, because there's an app which I bought for $3 or whatever, which you could in effect monitor a lot of the USGS gauging stations online and see. So I was looking at the Chappuxet River one down here, and to see what happens when it rains and so on.
Absolutely.
I was wondering if there was anything, if you could access this in real time.
Absolutely. If you go to this website, very prominent on that front page, that web page will be water data. And so all of our stream gauging sites and to some degree water quality stations that coincide with those sites at the same site are available online in near real time through that website. So anybody with a smartphone can go to ri.water.usgs.gov and get at flows. And another thing I want to mention is we also are very involved with flood work, flood monitoring, and our friend here from Warwick is gone, but we mark high water marks after the flood of 2010 at about 200 locations along all the major rivers, especially the ones that really flooded, like the Patuxent and areas in the immediate Narragansett Bay area. And one of the publications that's on this page is high water marks in Rhode Island. It's basically the XY locations, the latitude, longitude, and the heights of all the floods. And then there's an analysis of that 2010 flood in terms of how it stacks up with historic floods in Rhode Island. Probably about a 500-year flood, or 0.2% annual exceedance probability flood, which is how you're supposed to talk about it now. Doesn't mean it won't happen for another 500 years. What it means is you've got a 1 in 500 chance any given year to have that flood. And that report, which does a flood frequency analysis for essentially the Narragansett Bay watershed, is also up online, and that's a goldmine of information about flood issues for the state. FEMA was our cooperator on that, and we're working with them now to, in effect, redo all the FEMA maps, all the 100-year flood extent maps. And believe me, the Warwick treatment plant was one of the places we did we had high water marks. We know exactly how high it got there, and everything that Betty Ann was describing, we measured.
Oh,
so,
she knows that.
And then the last area that we're working in Rhode Island and have been for a long time is groundwater studies with the board. And as Ken pointed out, future water development in the Big River area most likely will be some kind of groundwater development out there in the future. And where the water is available, where the availability of groundwater is something we focus on as well. So.
I
Thank
had
you.
a simple question.
We're not done yet.
In Rhode Island, you had a monitoring station that you monitored nitrogen and phosphorus, and the trend lines were down in both, and the ratio was 8-to-1. Is that how the EPA sets the requirements at the sewage treatment plant?
Well, that's a good question. I mean, that has to do with, there is, and people who are at URI over at the GSO know this better than anybody, you know, there's a ratio of nitrogen to phosphorus that if you exceed, it tends to promote growth of algae because mostly, in say, Narragansett Bay, for example, let's just use that, it's going to be nitrogen limited. So it has all the phosphorus it needs, but if you get that nitrogen too high, it'll tend to promote algal growth. Whereas in fresh water, that nitrogen to phosphorus ratio, you know, it's phosphorus limited. So if what's going in, say from a treatment plant, has more phosphorus relative to nitrogen, then I always thought it was around 16-to-1, that so-called Redfield
8-to-1.
ratio.
Yeah.
But whatever that ratio is, that is part of what governs what's the limiting factor for algal growth. And I know that in fresh-water and saltwater, or marine waters, they're different. And EPA certainly pays attention to that when they set treatment standards.
Okay.
I'm sure. So.
Well, thank you very much.
Okay. Thank you very much.
Just-
And please
Yeah, sure.
take a copy of the Situate, our most recent Situate report.
Great, thank you.
Great. Thanks a lot. Is that it?
Thanks for coming.
Okay, thank you.